It has already started. I think maybe you've been moving that, or in fact even later. Or you can say anything before extend anything. So we are going to learn about extraction of aluminium. Okay? Are we fine? From which ore are we going to extract aluminium? From bauxite ore. And so ore is bauxite, which is aluminium oxide, 2 moles of water crystallization. Okay? Then we have got a lot of impurities which are found in the bauxite ore. These are the silica, into bracket, silicon dioxide, or silicon 4 oxide. Then we have which impurity again? We have iron 3 oxide in the ore. Iron 3 oxide. We have another one. We have titanium 4 oxide. We have titanium 4 oxide. Iron 3 oxide, this is Fe2 or 3. Then titanium 4 oxide, this is Ti or 2. That is titanium 4 oxide. So remember, if you want to extract aluminium, okay, our major emphasis is to get aluminium, okay? But we can only get aluminium from this ore, aluminium oxide 2 moles of water crystallization, which is the bauxite ore. So the impurities which are here, I need to first remove impurities all, okay? I don't want to see silica, I don't want to see iron 3 oxide, I don't want to see this water crystallization, I also don't want to see titanium 4 oxide. I want to first remain with aluminium oxide alone. Then from aluminium oxide, I can now go and get aluminium from it, okay? So the process of extraction takes place in 2. Process of extraction of aluminium occurs in 2 stages, okay? Number 1 stage is purification of the ore, okay? The bauxite ore. We purify the ore, okay? Then number 2, we are going to take the ore we have purified. We are going to go and electrolyze it between graphite electrodes or carbon electrodes. We go to electrolysis. And it occurs in electrolytic cell. We draw that. We drew it yesterday. So extraction of aluminium, we say we extract it from the ore called bauxite, and this is the formula. Then impurities which are there, we have silica, silicon dioxide, we have iron 3 oxide, Fe2O3, we have titanium 4 oxide. Then we say in the first step we are going to purify the ore, okay? Purification of the ore. So this is how we are going to purify the ore, okay? The ore consists of aluminium oxide, which is amphoteric. We have silica, silicon dioxide, which is acidic. This is an acidic oxide, okay? Silicon dioxide. Then we have iron 3 oxide, which is It's a basic oxide. Then titanium 4 oxide is also basic in nature, okay? So it does not dissolve in concentrated sodium hydroxide. Titanium 4 oxide and iron 3 oxide, these are basic oxides. You cannot dissolve them in a base, okay? Remember, sodium hydroxide is a base. It cannot dissolve basic oxides. For you to dissolve in sodium hydroxide, you must either be acidic or amphoteric, okay? So silicon dioxide being acidic, it is going to dissolve in hot concentrated sodium hydroxide. Solid reacting with OH gaseous will form sodium silicate plus water. Balance charges, I think the equation is balanced, okay? Then aluminium oxide, for it being amphoteric, it will dissolve in concentrated sodium hydroxide, forming sodium aluminate. But for us, we are going to write the ionic equation. So Al2, aluminium oxide, in solid state reacts with concentrated sodium hydroxide, will form sodium aluminate, which is AlOH4. Iron appears state. We balance the charges. How many moles of water are we going to add here? So I put my 2 there. So hydrogen here I've increased it to 8. So here hydrogen, how many hydrogen atoms do I have here? I have only 2, not so? So I need to create 6 of them here. To create 6, I have to add 3 moles of water. The equation balance in Al2, yeah. You get your 1.5 marks, that equation. So now here silicon dioxide, iron 3 oxide, okay, silica and this one they have dissolved also. But iron 3 oxide and titanium 4 oxide, they have refused to dissolve because for them they don't dissolve in sodium hydroxide. Now we are going to take the whole of them too for filtration, okay? When we go for filtration, actually in the solution, if this is the whole with its impurities, okay? In this, we have dissolved it in concentrated sodium hydroxide, okay? Here now, we are going to have silicate iron, okay? We are going to have aluminate iron, okay? Here, we are going to have in solution, we are going to have also titanium 4 oxide here. We are going to have iron 3 oxide. So now we are going to take them and filter them, okay? When we filter them, we are going to have silicate iron and aluminate iron as the filtrate, okay? Then titanium 4 oxide and iron 3 oxide, for them they will be the residue, and for us we are not interested in the residue. So our filtrate consists of aluminate iron and silicate iron, okay? Now here silicate iron is not of importance to us. We don't want it, okay? Our interest is in aluminate iron. What can I do so that I take away aluminate iron and silicate iron remain? What do? The first thing I do, I can add those freshly prepared aluminum hydroxides. If I had a freshly prepared aluminum hydroxide in a precipitation tank, the filtrate is taken to the precipitation tank, okay? When you take the filtrate to precipitation tank and you want to get aluminum hydroxide from this mixture, what you do, you can add, number one, you add freshly prepared aluminium hydroxide to precipitate aluminium hydroxide. Okay? We had freshly prepared aluminium hydroxide to precipitate aluminium hydroxide, which is there in the complex. So when you add freshly prepared aluminium hydroxide, we are going our AlOH4, this is the aluminate ion, in aqueous state. It is going to produce AlOH3, aluminium hydroxide, and takes away the OH. But this one, it has been precipitated, so aluminium hydroxide, this one here is in solid state. Are we okay? Now, if we are precipitated, I said there are two ways you can do, you can use in order to precipitate aluminium hydroxide. Number two, you can bubble carbon dioxide gas. When you bubble carbon dioxide gas, what will happen? This aluminate ion will react with the carbon dioxide gas. We shall form aluminium hydroxide, OH, solid plus carbonate ion plus 1 mole of water in liquid state. One, we have to balance. We balance charges first. So charges balanced. We also balance aluminium. So think the equation is balanced. Are you okay? So now you can choose in exam either of these two methods. You use one. You don't use both. In order to state aluminium, you use either of the two. You pick only one and use it. You can either have freshly prepared aluminium hydroxide to precipitate aluminium hydroxide, or you add carbon dioxide gas to the filtrate to precipitate aluminium hydroxide. So now, if you have precipitated aluminium hydroxide, in this solution, we are going to have OH in aqueous state. So, or if we use carbon dioxide, we are going to have carbonate. We are going to have carbonate ion. Okay? So we are going to still filter. Okay? We are going to filter that solution in order for us to get aluminium hydroxide pure. Okay? Yeah. So aluminium hydroxide, we shall go and filter. We are going to wash it. We are going to dry it a little bit. After drying it, we shall remain now with pure aluminium hydroxide in solid state. Okay? But our goal is to purify the whole. I don't want aluminium hydroxide in the purification process. I want to remain with aluminium oxide. Okay? So to remain with aluminium oxide, here what I will do, I'm going to heat this one strongly. Okay? When I heat aluminium hydroxide, I'm going to get aluminium oxide, of which we want. Okay? And then water. Water will be given when you're eating. Okay? So remain with aluminium oxide and water. So from here, we have now purified the whole. So the process of purification stops there. So now we come to step 2, electrolysis of the purified ore. Okay? So before we electrolyze this ore, what we are going to do, we shall dissolve this ore, aluminium oxide. It's first dissolved in molten cryolite. So when we dissolve it in molten cryolite, what do we form? Actually, what is the purpose of dissolving aluminium oxide in molten cryolite? To do what? to lower the melting point of aluminium oxide. Okay? Remember, aluminium oxide, ionic oxides, they have got very high melting point. Okay? Remember, for you to provide a temperature which is so high, it is very costly. Okay? So now what they do, in order for them to lower the melting point to around 800 there, to allow electrolysis to take place at around 800 to 900 degrees Celsius, molten cryolite is hardened, okay? Or aluminium oxide is dissolved in molten cryolite to lower the melting point of aluminium oxide. Now, after dissolving it in molten cryolite, aluminium oxide Al2 or D now becomes aluminium ion in liquid state plus oxide ion also in liquid state. We balance. Here I have Al2 here. So I put here 2, I put there 3. So 2 times 3, that is 6. Positive 6, 3 times 2, negative 6. Also, negative 6 and positive 6 give a net result of 0. So we have a charge of 0 here. Here we also have a charge of 0. Okay? There is no charge on either sides. So now, if I have my aluminium ion here, have my oxide ion there, what we shall do, we are going to electrolyze. After dissolving the aluminium oxide in molten cryolite, we write that equation, okay? It is then electrolyzed using carbon electrode. Can you please wake up a child? Okay? Please, you will appear in the video, Make sure you take their food, those are So I have aluminium ion and I have oxide ion. Now when we go to electrolyze it, okay? We shall go to the cathode, shall have the anode, okay? So at the cathode, aluminium ion is going to move and go to the cathode. When it goes to the cathode, it will get discharged to form the aluminium we want. So at the cathode, aluminium ion is going to get discharged. Okay? We form our aluminium Al in molten state. Are we okay? Then at the anode, we are going to form oxide ion for it because it had gained like 2 electrons, okay? Right now, for it, you want to become normal atom. If you get discharged, for it to get discharged, you must take away the electrons that bond. So from here, we shall have O, plus 4 moles of electrons. So, this is a gas, liquid 2, like that. Is it balancing? Charges of -4, charges of -4 here. 2 oxygen atoms. So, I think we are fine there. So we have formed this molten aluminium, okay? It will then be tapped in, it will then be tapped off. Oxygen will just go as a gas, escapes outside. You will breathe with it. Then after there's some complication which will take place. Remember, we use carbon anodes, okay? So when we use carbon anodes, carbon will tend to react with oxygen gas also and form carbon dioxide gas, solid gas, gaseous state, okay? So when carbon is able to react with oxygen, the electrons is reacting with oxygen also, So when the electron reacts with oxygen, the electron will keep on and decreasing. So they will ask you and tell you, explain why during the process of extraction of aluminium in the electrolytic process, okay? The anode keeps on decreasing. Why? The anode decreases, reason being oxygen being discharged reacts with the electron, carbon, okay? Form carbon dioxide gas. Are we okay? Are we fine? If you're dosing it, you start now, okay? Make sure you take the picture of those and dosing the class. Is the process clear? Yes. Say, you want to extract it from the bauxite. Extract aluminium from the bauxite, and the bauxite home. Impurities which are there, we have silica, iron 3 oxide, and titanium 4 oxide. So for us the first step we have to do is to first purify the ore. So in the process of purification of the ore, the first thing we do is to dissolve the whole ore in sodium hydroxide, concentrated one. So from there, aluminium oxide being amphoteric and silicon dioxide being acidic. For them, they will dissolve in concentrated sodium hydroxide, forming silicon dioxide will dissolve in concentrated sodium hydroxide to form sodium silicate and water. Then aluminium oxide being amphoteric, it will dissolve in concentrated sodium hydroxide and form sodium aluminate. It is a complex, it is soluble. So we shall, our titanium 4 oxide and iron 3 oxide, they don't dissolve in concentrated sodium hydroxide. Okay? Since they don't dissolve, for them we shall collect them as residues when you filter. Then silicate iron and aluminate iron, they will be in the filtrate. Okay? So now we take our filtrate to a precipitation tank. So when you take the filtrate to the precipitation tank, we are not now interested in silicate iron, but we want to get aluminum hydroxide from aluminate iron. Okay? The filtrate consists of this and that, but our interest is on this. This one is of no use now because it's an impurity. Okay? Yes. So to purify this, we can either add freshly prepared aluminum hydroxide to precipitate aluminum hydroxide. Okay? What we have added help to precipitate the rest which are inside there in the complex. Here. We form aluminum hydroxide plus OH. Then we can also bubble carbon dioxide gas. When we bubble carbon dioxide gas, shall form aluminum hydroxide, carbonate iron, water. Our point of interest is this. But remember, we are purifying the ore. We want to remain with aluminum oxide only, even no whole mode of crystallization is needed. Okay? Yeah. So here we are going to heat the aluminum hydroxide formed after cleaning it very well and drying it. Heat it. We form now our new ore. We have now purified the ore, aluminum oxide. So after purifying the ore, we come and electrolyze it. But before the electrolysis, we are going to dissolve the aluminum oxide in molten crystalline to lower its melting point. Okay? So when we lower the melting point, we now electrolyze it at a temperature of 800 to 900 degrees Celsius. So at the cathode, aluminum ion will get discharged to form aluminum. Then the anode, and the anode oxide ion will be discharged to form oxygen gas. Aluminium is then tapped off as a liquid. Then maybe they take it to industry to purify them and make changes on them. Okay? Yes.